Alright, hello everybody. I'm going to show you how to make your subwoofer actually follow the curve it's supposed to be following when you run Magic Beans. I don't know if it's just me, but for some reason, when I run Magic Beans True Target, it really doesn't do anything to my subwoofer. So this purple line is my subwoofer frequency response, and this green line is after using MiniDSP to correct it, to follow the line, the curve that gives you. This red curve is what you get if you export from Magic Beans to Dirac Live. It gives you these text files, and you can just drag them in, and they look like this. So it'll say breakpoints and then give you a bunch of numbers, and literally you just drag it in, and it'll give you the curve for each speaker. I use the center speaker. The low end is pretty much the same on all of them, so it really doesn't matter what you use, but I just use the center speaker. And you can also export as multi-EQX curves and drag those in, and that'll tell you what it's actually doing to each speaker, the actual filters. So like for example, this is my LFE one, the multi-EQX curves file. So what it's doing is it's boosting around 55 hertz, a couple dB, and then it's cutting a little bit right here, and then it's boosting right here. I don't know what Magic Beans is smoking, but how are you going to turn this to this with that? I just don't get it. Maybe I'm doing it wrong, but basically the purple line is with the Magic Beans correction, no level change, nothing. For somehow it's supposed to match this curve. I don't know. So anyway, how you get it to match the curve is you I'll turn these off so you can see it better. Is you take your LFE measurement, you find the Dirac for center, you open that up, you erase breakpoints, and then you can erase everything after like 350 or whatever. And then you save this as, I already have one, but you just save it as like LFE EQ Curve for REW or whatever. And then you take your LFE measurement, and then you go to EQ. Actually, I should click this one. Go to EQ. Open, I already have the curve open. Go to limits, fit to data so you can see everything, and basically just bring this curve up in level. This curve, the blue curve being that LFE thing you just saved. You bring it up so the blue line meets the lowest part of your sub response, which is for me 20 hertz. It's a sealed subwoofer. It's a good subwoofer, but it's sealed, so it has a natural roll off. And then once that is that, set this to 20 to like I guess 350. Set the boost to 0, then match to target. Press OK. And what that's gonna do, oh sorry, you have to set it to 148 and then match response. That'll give you some better filters, some more precise filters. So what that's doing is it's taking this subwoofer response, and actually, I just figured this out myself. You should set it to 148 smoothing and then adjust the line of the curve. That's gonna make it a lot better. I'm gonna have to redo that for mine. And then, oh, for some reason doesn't want to do it. See, this is like a trial and error sort of thing. If you have MiniDSP and use REW, you know what I'm talking about. We could bring this back up. Sorry guys. Alright, filter test, match response to target. Set it to 148. Alright, anyway, so now you created the filters to make this dark purple line follow the blue line. You saved coefficients to file. I'm gonna save it as a text file. Then you go to MiniDSP, and I already have it on my subwoofer, but let me use this as an example since I'm not using this. Go to PEQ, load biquads, and then wherever I ended up saving this. I don't know where I saved. Oh, there it is. Load that in. That'll give you the filters, and when you measure that, should be pretty close. Mine ended up like this last night when I did this orange line. See, there's like still like a boost for some reason at this point. So what you could do is take measurement 14, which is the sub PEQ, go to EQ again, and you literally just do the exact same thing, and you match response to target, and that give you a little bit more filters that you then save to a file, and you put on your input side. Say I put the same filters right there. You would just go to load by quads. See, I have input filters. You load those up, and with those two sets of filters, you should get something like this green line. See, it went from this orange line to the green line, and it went from that to that. So it's not perfect. You would have to iterate upon it, but yeah, that's basically it. And then when you run, see if you run the C and then the LFE, and then you can run the C and LFE together and create filters that way if you want. But yeah, that's how I do it. One last thing, when you do these filters, you're gonna have to raise the overall volume of the subwoofer to have it match. So this is the original, and then I had to drop the volume about 13 decibels for this to meet this. And as you can see, the 20 hertz is just lower since we're just cutting all this high-end stuff, this 50 to 150 hertz. We're cutting that to fit the curve. We're not boosting anything. So once you cut all this, it's going to basically look like this, except it's going to be roughly like that. So you're going to have to go into your MiniDSP, and when I took my original measurement, it was like -27 or something like that. So I boosted up to -10. It just depends on how capable your subwoofer is. I mean, if your subwoofer really can't do 20 hertz, you might just have to settle for aligning 30 hertz or 40 hertz, depending on whatever your subwoofer can do without maxing out the subwoofer gain knob and maxing out MiniDSP and maxing out the AVR sublevel. I just have my subwoofer at half gain, and then I don't think I ever really boost levels in MiniDSP because I heard that it could just stress the MiniDSP or something, or clip it or something. So you're gonna have to play with that because maybe you won't have the ability with your current subwoofer to align 20 hertz. So you might have to settle for 30 hertz. So yeah.